Hi, and welcome to the Wayne Lamos podcast. I'm your host, Wayne Lamos, and we are on episode 3 of the second mini-series, Understanding and Not Judging the Angry Young Man, episode titled, Understanding Nutrition and Anger for the Common Man. First, I'd like to put up a disclaimer over here. Please do consult a licensed dietitian or nutritionist or your medical specialist. Making any changes to your diet, in case you have diabetes, thyroid conditions, blood pressure, or other issues, could be a very serious thing and need expert advice. And I won't be held responsible if you go ahead without any expert consultation and something may go wrong. Right, that being said, let's go ahead. In the lineup, we're going to be looking at magnesium, zinc, B vitamins B1 and B6, omega-3 and ginger, and find out how they affect anger. And then we're going to be looking at fructose, alcohol, caffeine, and smoking, and how they also play a role in anger. We start off with magnesium. On a biochemical level, more than 325 enzymes are dependent on magnesium out of approximately 1,300 in the human body. A deficiency could cause irritability, lack of self-control, agitation, and a hair-trigger temper. Here, studies have shown an increased plasma magnesium level, as well as increased magnesium in the urine of people with acute stress. This is because it's the body trying to protect itself from stress. Magnesium deficiency lowers a person's tolerance to stress. Here we also see an impairment in hippocampus-dependent memory. As stated in an earlier episode, anger is usually a secondary emotion, with a primary emotion under it like fear. So we also have to consider nutrition for anxiety. In order for that, please refer to Series 1, Let's Make Psychology Common Living Culture, episode Nutritional Mentions for Anxiety and Anxiety Disorders. Moving on, we go on to zinc. With zinc, we are looking at zinc in correlation to the vagus nerve. In general, zinc is necessary for the nervous system. We are now going to try and understand why it's mentioned that zinc helps in the control of anger and hostility. The vagus nerve plays a role in efficient emotion recognition with regards to safety and survival. Studies have shown that a stimulated vagus nerve enhances the recognition of anger while reducing the recognition of sadness. Zinc increases BDNF, that's brain-derived neurotrophic factor. One of the vagus nerve's functions is BDNF mRNA expressions in the adult hippocampus. mRNA standing for messenger RNA. RNA is ribonucleic acid, a molecule necessary in biological coding, decoding, regulation, and expression of genes. Low BDNF has been linked to anger. Also note that low levels of serotonin and high levels of cortisol have also been linked to low BDNF. Next, we move on to vitamin B1, also called thiamine. B1 is required for metabolism and for conducting of nerve signals. It plays an important role in brain function, and its deficiencies have been linked to Alzheimer's, where glucose metabolism had diminished in many brain regions, but improved with the administration of vitamin B1. With respect to Alzheimer's and dementia, questions have been raised if reductions in glucose metabolism could have been a reason for Alzheimer's disease. Getting back to vitamin B1 in correlation to anger, let us look at the hippocampus. Hippocampus deficiencies in B1 have shown a decrease in neurons in the hippocampus regions CA1, CA3, and the dentate gyrus, that's DG regions. To understand what that means, let's look at what happens in the CA1, CA3, and dentate gyrus. In CA1, neurons are necessary for the formation and consolidation of hippocampal dependent memories. In CA3, neurons are responsible for the associations between spatial location and object reward, besides roles in neurodegeneration and seizures. And in the dentate gyrus, neurons play a role in the formation of new memories and spontaneous exploration of new environments. Here we can make the correlation out if you were to look at neurons' function in CA3 and the dentate gyrus itself. Next, we look at vitamin B6, which is necessary for the creating of neurotransmitters, meaning it is needed for the synthesis of GABA, serotonin, dopamine, histamine, and others. To understand the significance of this, let us understand that GABA is required for a calming effect by decreasing activity in the nervous system. Serotonin modulates the amygdala, you say tomatoes, I say tomatoes, which is mentioned a few times before, processes fearful and threatening stimuli and has a direct role in the detection of threat and activation of the necessary fear-related behaviors. Moving on to omega-3, here we first look at grey matter, 50% of which is composed of fatty acids, out of which one-third comprises of omega-3s. Omega-3 is necessary for hippocampal neurogenesis as well as hippocampal-dependent memory tasks. Here again we look at hippocampal regions CA1, CA3, and the dentate gyrus DG. Here, studies have shown that the introduction of omega-3 balanced out arachidonic acid and also increases DHA. Here we understand that arachidonic acids, high levels, lead to anger and irritability. Moving on, we move on to vitamin D3. Vitamin D helps in regulating the immune system and also plays a very important role in balancing calcium by helping the body absorb calcium. Hypercalcemia is a condition where there is too much calcium in the blood, and this could cause cognitive changes, including psychosis, and could also lead to neuronal demise. Next we have ginger. It is known to calm anxiety, as we have mentioned in a previous episode, and works as well as a benzodiazepine drug. It is mentioned to increase serotonin and dopamine and lower cortisol. What's also interesting is that studies have shown that the consumption of ginger has led to less judgmental behaviors and a high tolerance for disgust. Now let us take a look at what all could contribute towards anger. We start with fructose, large amounts of fructose. In general, sugar has been linked to temper tantrums in children. Here, a hypothesis published in Evolution and Human Behavior points to the role of fructose and claims that fructose, by lowering energy levels in cells, triggers a foraging response not dissimilar to starvation. Dr. Richard Johnson, MD, professor at the University of Colorado School of Medicine, has stated that the fructose pathway was one for survival, but the intake of fructose nowadays has increased greatly. He attributes aggression to excess sugar in children to fructose. How fructose lowers energy levels in cells is that fructose requires ATP for its metabolism, and ATP is generated by a cell's mitochondria. We move on to number 2, which is alcohol. Alcohol blocks the absorption of magnesium and zinc and increases the activity in the amygdala. Studies have shown direct correlations between alcohol and anger, as you now can imagine, as you now know what magnesium and what zinc also do and the function of the amygdala. Here we also understand that chronic alcohol consumption can affect the hippocampus via shrinking and the function of the hippocampus region CA3 associated with spatial location and object reward. Next, we are moving on to caffeine. In reference to caffeine, there are a lot of varying conclusions, some for, some against, and I'm going to go for the safest mention, which is the line in between, which would state that up to 250 mg of caffeine increases elation in a healthy person, mind you, not a caffeine sensitive person and not children, and 500 mg increases irritability. To understand that, let's look at Nescafe instant coffees, Blend 43 and Gold. The caffeine content in a Nescafe instant is about 100 mg to 180 mg per 4 grams, where a teaspoon holds about 4.2 grams. Here we also mention a separate study in which high habitual coffee drinkers of about 300 mg daily and low habitual coffee drinkers of about 100 mg daily were taken, and over a 5-day period were given caffeine of 0, 100, 200 and 400 mgs, and on the last day their normal caffeine levels. Here it was noticed that the high habitual caffeine drinkers showed greater impulsivity, that's acting before deliberating, as compared to the low habitual caffeine drinkers, meaning caffeine in chronic caffeine drinking can lead to people being more impulsive. Here in another mention also, it was stated that acute drinking of caffeine was said to enhance non-aggressive responding to monetary rewards. So you guys decide. I'm going to stick with the safest line, as I mentioned earlier. Up to 250 mg of caffeine increases elation, and above 500 mg increases irritability in healthy people. Lastly, we move on to smoking. Here, while the act of smoking itself gives a calming effect, studies have shown anger and irritability within the first 24 hours of withdrawal. Here we understand that chronic nicotine exposure induces long-term modifications in a specific pathway in the amygdala. To understand that better, nicotine causes LTM, that's long-term potentiation, a persistent increase in synaptic strength of a chemical synapses in the cortical lateral amygdala pathway, and it interferes with GABA. Next, we move on to smoking. Here, while the act of smoking itself gives a calming effect, studies have shown anger and irritability within the first 24 hours of withdrawal. To understand smoking's effect with anger, we have to look at chronic nicotine exposure, which induces long-term modifications in a specific pathway of the amygdala, or better understood as nicotine causing LTP, long-term potentiation. Potentiation being a persistent increase in synaptic strength of a chemical synapses in the cortical lateral amygdala pathway, where it interferes with GABA. Well, that's it for this episode of the Wayne Lemos podcast, recorded for community and recorded for you. Coping skills for anger will be our next topic on our next episode, so do look out for that. Till then, this is your host Wayne Lemos, thanking you for tuning in.